Hi everyone, Mike here again, and in this video I'm going to be going over how to do production studies with Inventor. So a production study basically is simulating a carrier moving throughout a section of conveyor in order to check for clearances. So assuming you watched the video on how to set up these carriers and curves, you could have a situation like this. So right now what you see here is two carriers in the same sketch that can be moved independently. See, that one moves like that, and that one moves like that. So in a production study, it may become necessary to check for clearances between two products on two different carriers. So that's why these two different carriers are necessary to have in the same sketch. However, these carriers right now are moving independently from each other, but in a production study, they have the spacing between them has to be determined by a set job center distance. So, if you recall in the last video, there's this job center parameter that determined distance, and we also have that here, but in this case, that job center is controlling the length of this spline here. So this spline is divided up into 10 segments, and each segment has the dimension of job center divided by 10. So if I change this job center parameter, the overall length of the spline changes. So since the job center is going to be wrapping around curves and whatnot, it has to be flexible like this, which is why it's a spline. So what I'm going to do now is I'm going to take this end of the spline and constrain it to the front trolley of one carrier, take the other end, constrain it to the front trolley here, and all these intermediate points here I'm going to constrain to the spline. Okay, so that's done. So let's just take a measurement here. So if we select this curve here to measure, we can see here that that length is specified to be 275.007 as opposed to 275, which is the job center parameter. So there's always going to be a slight bit of deviation, but the advantage of using the spline to determine the job center distance is that you can wrap around curves and still maintain a fairly accurate distance. So if we measure this now, you have 275.039 wrapped around a curve. So as you can see, these two carriers now are constrained together so that they can move together. So what we're going to do now is simulate this motion. So since they all move together, this entire assembly here can all be driven by one dimension. See, it's constrained there, so you can change it there to go to one position, change it there to go to another position. So now that these carriers have been set up, we need to determine what it is we're going to be studying. So let's say, for example, we want to study the distance between the bottom part of this product to the tow bar here. So what we can do is we can take a line, draw from any point of interest on down. We can constrain it as we need to. What we're going to do here is we're going to add a dimension but we're going to make sure that it's a driven dimension so that it doesn't constrain the assembly in place. It'll just provide us with a reference value. And say we also want to determine the distance in the back here. We can apply the same principle from there to there. Add another reference dimension. And say finally we want to determine the closest these two carriers ever get to one another. So let's go from there to there. And have another reference dimension there. And let's say also we want to track the path of a specific point of interest as it moves throughout the entire curve. We can also do that, but that point has to be referenced from the origin here. So say I want this point here, it has to reference from the origin, goes there for the x dimension, and goes there for the y dimension. So now that we have everything that we want to study, we need to assign labels to it. So if I go into the parameters here, everything including the reference dimensions are here. We just need to give them labels. So this 400 inches here that controls the position, we're going to call that driver. These dimensions here that are clearance points or pinch points, we're going to label those as such. So this 19 inches is here, and we're going to call that C1. This 7.2 inches here, we're going to call C2. This 37 inches, we're going to call C3. And for points of interest reference to the origin, we can get this back. The x dimension is going to be called x1, and the y dimension is going to be called y1. So these are labeled as such for a reason. So let's go here, because we're going to export all this data into Excel, and these are labeled as such. So Inventor is going to read the values of all these reference dimensions as the carrier assembly moves through the path and export each iteration to a separate row in Excel. So we need to find a way to automate this, and we're going to do this with iLogic. So if we go to the Manage tab, add rule, production, this rule is going to be suppressed at the start, and it's going to have the following code template. So this is the code template that is used to automate the production study, and I'll provide this in the description. So what it is you first specify the path of your master data file, which I'll also provide in the description. And it controls the production study by modifying the driver dimension in set increments. So you have a start point here, an end point here, and an increment here. And with each increment, it's going to read the value of the parameter of interest and export that value into a different row in Excel. So right now we have the driver parameter, the x1 and y1 parameter here, and our c1 through C3 parameters here. We also have those here and here. So if you need more points of interest or more clearance dimensions, you can just uncomment these lines there. So once that's done, you should be able to right click and run the rule. And you can see what it's doing here. it's simulating that motion. Alright, so that finished doing what it did, and now once that's over, we can find the master data file. We can open that up and we see that the Excel file has now been populated. So right now this is sorted by driver value, but say for example you wanted to sort by the C1 value to find out what's the worst case scenario there. And we see that happens at the driver value of 630. And if we go back here and change the driver value to 630, you can see that that corresponds there to there, and you could also do so with all these others. So C2 worst case scenario is at 680. That's there. And then C3 worst case scenario is at 790, and that's there. So I hope you can see that this is quite a flexible tool and allows you to analyze many points of interest at the same time. So now we're going to take a look at this point of interest here, which we wanted to analyze throughout the entire curve. So that data, that XY data, got exported here, and if we sort by driver value here, we can see that in order. And right now we want to show the path of that motion. So since all those points are available to us, we can implement a macro that we've already used. So if we go to the Tools tab, the VBA editor, load project, import points as we did in the curve setup. That's there. And this sheet 2 here just has everything formatted into Inventor's units and the format that the macro uses. So if that's that, we can go run this. You see it imports the points there. And once the points are finished importing, you can draw a spline to represent the path of motion of one specific point. So that's essentially how production studies are done with Inventor. Hopefully you've learned something here, and thank you for watching.